All right, in this video I'm going to be recording solutions for BC Homework 1.2, and that's over limits involving infinity and asymptotes and stuff like that. So the first one, the first set of problems, it's asking us to write the equation of any horizontal asymptote to the graph of the function. And okay, the first one is this here. And so when we talk about horizontal asymptotes, we need to be considering the limit as x goes to infinity and the limit as x goes to negative infinity. Okay, so the limit of this thing as x goes to infinity is going to be, okay, this is one of those double horizontal asymptote situations when you have the square root of an even power of x. You just kind of got to know that. The limit of y as x goes to infinity is positive over positive, right? Because the square root, if it's already written down for you, that means it's a positive square root. And then this, you put a positive number into the third power, that's going to be positive, okay? And so that's going to be positive 2 over the square root of 9. Okay, because they're essentially the same, I'm going to divide the leading coefficients. Okay, but as x approaches negative infinity, y is going to go towards 2 times a negative number to the third power, which is going to be a negative number, right? So it's going to be negative divided by, well, this is positive because it's a square root of a positive number. And that's going to end up being negative 2 divided by 9. So the equations of my horizontal asymptotes are y equals 2/3 and y equals negative 2/3. Okay. Number 2, I've got y equals 5 log x over 8x squared. Okay, and this is okay, we're going to need to consider the limit as x goes to infinity. It says a natural log, so it's not going to make sense for me to consider the limit as x approaches negative infinity because that's outside of the domain of natural log, right? That can only take in positive numbers right there. Okay, so the limit as x goes to infinity of 5 log x over 8x squared is 0 because it's heavier on bottom. Okay, this grows faster. Log does not grow fast at all. 8x squared grows much faster. Okay, it's bigger on bottom, that goes to 0. So the horizontal asymptote is going to be y equals 0. Okay. The third one, y equals cosine of x over x squared plus 4. Okay, this one, okay, you might be like, it's a lot of stuff going on here. This is not just a fraction for me to determine which is bigger, right? Well, what you're going to do is you're going to consider the limit as x approaches infinity of just the fraction. We'll start with fraction, then we'll take cosine because we know a little bit about cosine. We know enough, probably. So in the inside of the fraction, it's bigger on bottom, right? X squared on bottom, just 1 power of x in the top. That means, well, and actually, if you think about it, the limit as x approaches negative infinity, it's going to be the same thing. It's going to be bigger on bottom, so it's going to go to 0. So the limit as x approaches plus or minus infinity of cosine of x over x squared plus 4 is going to be equal to the cosine of 0, right? And that's equal to 1. I'm still in my shot? Yes, I am. Okay. And that means that since the limit as x approaches infinity and negative infinity of this function is 1, that y equals 1 will be a horizontal asymptote to the graph of the function. Okay. Moving on to number 4. All right, I've got y equals 2x to the 99 power divided by 5e to the x minus 3. Okay, and so what I need to do is I need to consider the limit as x approaches infinity and the limit as x approaches negative infinity. And these are going to be two different things because I've got exponential involved, right? All right, so the limit as x approaches infinity of 2x to the 99 divided by 5e to the x minus 3 is going to be 0 because it's bigger on bottom. Okay, exponential is bigger than algebraic or polynomial, no matter the power. So e to the x does eventually grow faster than x to the 90. If you're sitting there thinking like, dude, I don't believe you on that, like I'm going to need more evidence, I'm going to ask that you remain patient and wait for maybe a month or two until we get L'Hopital's rule, and then I will be able to prove to you, without a doubt, that this limit is in fact 0. Okay, but for now you're just going to have to take it on faith. Now, as x approaches negative infinity, 2x to the 99 is approaching negative infinity because you put a negative number to an odd power, it's going to come back negative. Double it, even more negative. Over 5 times something that's getting really close to 0 minus 3. Okay, so, you know, this is really going to negative infinity. But it only asks for the horizontal asymptote, so I'm going to say y equals 0. Okay, but in the discussion of horizontal asymptotes, you have to be considering limits at infinity, and I figured that I would just, you know, evaluate that limit for you as well. All right. Now, number 5. Okay, yeah, y equals 3x minus 1 squared over negative 2x squared plus 5x. Okay, this is essentially the same on top and bottom, so whatever it's going to do to infinity, it's going to do the same thing to negative infinity. So I'm going to, just a second, I'm going to, what am I going to do? Oh, I'm going to actually expand this because I know it's going to be a squared situation on top and bottom. Yeah. So what I'm going to do, though, is I'm going to say, well, 3x minus 1, if I was to, you know, write it and square it and do FOIL and everything, I know the first thing I would get would be 9x squared. And then I know that that's the only x squared term I'm going to get. So I'm going to just put a dot, dot, dot there because I know it doesn't matter. And I've got a negative 2x squared plus 5x. And I know that the only horizontal asymptote to this is going to be y equals 9 divided by negative 2. Okay. Now for these next ones, let's see. Okay, this is just find the limit. So the limit as x approaches 2 from the positive side of x minus 2 divided by the absolute value of x minus 2. Okay. Now, you know, if you don't just see this and recognize, hey, wait, this is related to a function that I just know the graph of, I'm supposed to know what it looks like. You know, maybe you didn't remember that, and you saw that we weren't approaching infinity, try plugging in. Well, you're going to get 0 over 0, and it's like, okay, that's not great. That's not a suitable answer. And so I need to do something else. And what you're supposed to do with this is you're supposed to know, okay, hold on just a second. Let me get a different colored pen and draw you a picture of the graph of y equals x divided by the absolute value of x, right? That looks like this. 1, negative 1, right? Well, if I'm just going to replace x with x minus 2, that's a translation right by 2 units, okay? So this is going to be, I'm looking at, there's x equals 2. There's my, function. And maybe I say that, this is right here, negative 1, and this is 1. Okay. Now, if we're talking about the limit as x approaches 2 from the positive side, that's looking like 1. Okay. You could think about 2.1, 2.01, 2.001. I don't really like the numeric approach to limits, but that's something you could consider, and it's always going to be 1. So this limit is equal to 1. Okay. Had it been 2 from the negative side, that limit would be negative 1. Okay. Number 7. I think I can fit this in. The limit as x approaches 5 from the positive side of x over x squared minus 25. Okay, again, this is not a limit at infinity, so I would recommend just plugging in, right? But you plug in, and this is going to be 5 over 0. And it's like, oh, that's not good. Okay, but you remember me saying maybe that number divided by 0, like non-zero divided by 0, that's game over. There's nothing we can do for that. It's going to either be infinity or negative infinity. It's just our job to figure out which one it is. It's a vertical asymptote, so I'm going to just put in vertical asymptote. And I'm going to figure what's happening, it's something a little bit bigger than 5. So at 5.1, I'm going to have a positive, I'm just going to say 5.1, right? Because I know that 5.1 squared has to be bigger than 25. So it's positive divided by positive. I don't know what it is, but I know that we're going to be able to go like that. Okay. And, well, because I'm going at a vertical asymptote and I'm already positive, this limit is going to be positive infinity. We do need to be able to distinguish between positive and negative infinity in a situation like this. Okay, number 8. That's kind of, I think, what I was getting at, where it's like every once in a while you just plug in on it and it works out, right? Find the top corner. All right. t approaches 1.5 sine of pi t. 1.5 is like 3 over 2. So I'm going to just try plugging in and see what happens. That's going to be equal to, let me move the actual problems out of the way, make sure I have enough room in my shot. I do sine of 3 pi over 2, and that's a -1, right? Think about 3 pi over 2 is down here at the very bottom. What's the y coordinate there? That's -1. Okay. Number 9. X goes to infinity, 3e to the x plus 1. 3e to the x plus 1 over 3 minus e to the x. As x goes to infinity, I'm looking for the biggest thing, and that's going to be 3e to the x and -e to the x. Okay, essentially the same. I'm going to divide the leading coefficient. So that's 3 divided by -1. Okay, but hopefully, yeah, number 10 is going to ask about the limit as x approaches -infinity of 3e to the x plus 1 over 3 minus e to the x. And as x goes to -infinity, I told you in class, these e to the x's, they go to 0, right? So this is approaching 3 times 0 plus 1, which is 0 plus 1, over 3 minus 0, which is going to be 1/3. Okay, so, very different limits there. Number 11. Oh, okay. Number 11, this is a good example. Okay. The limit x going to -infinity of x minus 1 divided by the square root of x squared plus 1. Okay. Now as x approaches -infinity, I've got, this is one of those ones where you have to be careful because of a potential double horizontal asymptote. So I know that I have to be careful about the sign. As x approaches -infinity, x minus 1 is going to be negative, specifically. And then down here, I've got the square root of x squared plus 1. No matter what x is, that's always going to be positive, right? Because x squared plus 1 is always a positive number. You can go and take the square root, it's going to be positive. Okay, so I know my answer is going to be negative, right? So I divide the leading coefficients, and 1 over 1 is -1, right? Okay. And then, oh, I like this one. I don't remember this one from the quiz, but I think this is the old version of the quiz. Maybe this one. I don't remember. It's been a couple years. Limit as x approaches infinity of x to the 3 divided by x squared plus 1. Okay, this is bigger on top. There is no horizontal asymptote, so it's not going to be a real number. Okay, it's going to be one of the infinities. But what you need to do is you need to say, okay, I've got x to the 3rd on top, x to the 2 on bottom. In some way, this is like y equals x. At least in its end behavior. How about that? Okay, if you went and actually did the long division, it would be x plus or minus some number over x squared plus 1. Okay, and that's not. Well, I forgot what I was going to say about that. Anyway, it's like y equals x, and we know what that looks like. So we know that the limit as x approaches negative thing is going to be -infinity. All right. Now, on the back side, let's see. I think I gave out all my copies of this homework. Evidently, I just had barely enough. Let me just draw you my sketch artist rendition of this curve. I think really the issue is that it's got an asymptote at x equals -1, and I don't know why there's a vertical line there. That's a little weird. Oh, and that's it. There appears to be a horizontal asymptote at y equals 0 as we go to the negative direction. But maybe I can draw this for you. But you're probably sitting and looking at this sheet of paper yourself, so. Okay. So like that, that's 2. Okay, I've got a vertical asymptote here at -1. Need a little bit of negative space, and it looks kind of like that. Right? Okay. And, all right, that's what we got. So the limit, so I'm just kind of brush through these. X to 1 from x to -1 from the negative side. From the negative side, we're going down here to -infinity. Okay, the limit as x approaches -1 from the positive side of f of x. From the positive side, it's going to positive infinity. Okay, number 15, the limit as x approaches -1 of f of x does not exist because of disagreement right here in one-sided limits. Whoops, you could not see that. Pardon me. 14, 15, 16, the limit as x approaches -infinity of f of x does appear to be 0, especially on the graph. All right, and yeah, kind of the crown jewel of this problem, which is definitely related to a particular item on the test. Okay, I know I'm going to use it. I use it every year. It's a classic AP multiple choice question. So if y equals x minus 6 over 3x squared plus a, use the graph to find the value of a. Well, what you know is that there's a vertical asymptote at x equals -1, meaning that when x is equal to -1, I need to have division by 0. So that means 3 times -1 squared plus a needs to equal 0. Okay, so I've got 3 plus a equals 0, a equals -3, and that's going to be all I think. Wait, no, I'm going to do the extra practice problems. Hold on, let me pull those up real quick. Oh, that's not good. I'm going to have to dig them up out of Google Drive. I had hoped I had those just offhand, but that's all right. Where is it? Practice 1.2. Here we go. All right, find the limit. Okay, I think that I'm looking at these, and this is going to be, I'm going to have to record this separately. Yeah, and so I'll put it on, you'll be able to see it wherever you got the link for this video probably. Okay, and that I will just label this on my channel just more infinity related limits or something like that. But it's going to be a separate video. That's all for this one.